Today's topic is silicon control rectifier. It is a type of semiconducting devices. So at the name represents that the silicon is a type of a semiconductor. So that the silicon control rectifier is commonly called as the SCR. In this session, we are going to discuss the modes of operation of SCR and VA characteristics of SCR. So before getting into the topic, we should have an understanding of the thyristor family. So these three are included in a thyristor family. The first one is the SCR, that is a silicon control rectifier. Here we have a symbolic representation of a SCR. So here we have three terminals, that is the anode, and another one is a cathode, and another one is a gate. So second one is the gate turn off thyristor, that is commonly called as the GTO. So here it is the symbol representation of a GTO. Here also we have three terminals, that is the anode, cathode and gate. So the difference between the SCR and GTO is, here you can, in SCR you can control only the turn on process, but not the turn off process. That means that the turn off process is a commutation process. You can turn on by gate, by using the gate terminal, but you cannot turn off the SCR simply by removing the gate. You need an external circuit. But when coming to the gate turn off thyristor, you can turn on and turn off the device by using the same terminal. So it makes the device operation very simple. And the third one is triac. So triac is also called as a bidirectional thyristor. So here is the symbolic representation of a triac. So it is nothing but, it's just like a SCR, but the two SCRs are connected in anti-parallel. That the one terminal is taken as a A1 or MT1 and another terminal is taken as a A2 or MT2. And as same as the above two, that the gate terminal is here. So that the MT1 is nothing but, that is the main terminal 1 and main terminal 2. That the bidirectional, that means nothing, bi means 2. Bidirectional means that the current flows from anode to cathode as well as the cathode to anode. Here that the current flows from MT1 to MT2 and also MT2 to MT1. But in a silicon control rectifier, that the semiconducting device is a unidirectional. That means that the current flow from anode to cathode alone. It doesn't flows from cathode to anode. So that is the difference between the SCR and the triac, and that the turn on and turn off process difference between the SCR and GTO. So coming to the topic, here is the construction, simple construction view of a SCR. So here we have three terminals and 4 layers and 3 junction. As we know that the one terminal is the anode and another one is the cathode and another one is the gate. So here is the symbol view. As I said earlier, that the SCR is a unidirectional device. That means that the current flows from anode to cathode, and also that it is a semi-controlled device. You can turn on the SCR using the gate current and turn off by the external circuit. And also it is called as a charge controlled device. Why it is a charge controlled device means you can control this device by the magnitude of the charge you have applied to the gate. So this is the ideal VI characteristic. So consider this circuit. So here it is a bipolar device that blocks the both polarity voltages. So modes of operation. There are 3 modes. The one is the forward blocking mode, and another one is the forward conduction mode, and another one is the reverse blocking mode. So in a forward blocking mode, you can apply the anode cathode voltage that is greater than 0. That means that the anode cathode voltage is positive and that the gate current is 0. When it comes to the forward conduction mode, that the anode cathode voltage is positive as same, that we are going to apply above the 0, and that the gate current is not equal to 0 means that we are going to apply the gate current is positive. So reverse blocking mode, here we have applied the reverse bias. That means that the anode is negative with respect to cathode. That means that we are going to give a below 0 anode cathode voltage, and that the gate current is equal to 0. So this is a forward blocking mode. So here BAK is greater than 0 and gate current is equal to 0. So here we have apply a anode is positive with respect to cathode. That means that this is a SCR structure. So PN. Here we are having a 3 junctions. So here we are going to know the operation of the 3 junctions. So what are the junctions? J1, J2 and J3, and what you are going to be. So here anode is positive with respect to cathode, as said that the gate current is equal to 0. That means that the gate is open. So it works in a, that means it operates in a reverse bias mode. So reverse bias mode means there is a no conduction, but that the small leakage current flows. So the second one is the forward conduction mode. Here we have applied the anode cathode voltage is greater than 0, that means positive, and that the gate current is not equal to 0, that means gate current is positive. Here see, so that here we have applied the anode current is positive and with respect to cathode, that means anode is positive, cathode is negative, that means it is forward biased, and gate is positive and with respect to cathode. So positive, negative. Here we have applied. So what is the operation here? That the current flows from anode to cathode. Why? That the positive voltage is applied here. So here it is the positive voltage. Here anode. So anode is connected to the P layer. P majority carrier is positive carrier. So that the hole is the majority carrier in a P layer, and the electrons are the majority carrier in a N layer. If that the holes are the majority carrier in a P layer, here also the same positive terminal is here. So that the same poles repel each other. So that the majority carriers are moves from P to N layer, and here the majority carrier of the electrons moves from N to P layer, so that the junction is crossed, so it is act as a forward bias. If it is a forward bias, if we are taking that as a switch, if it is a forward bias, that is a closed switch. If it is a reverse bias, that is a open switch. So here it is a forward biased, as here, as same here. So here we are applying the negative supply. Here that the N is connected to the negative supply, that the N layer having a majority carrier of electrons, and here are a negative. So same charge carriers repel each other, so that the majority of N will goes here, and P crosses the junction. Here also that the carriers crosses the junction, so that the junction 3 also act as a forward bias. So it is also a closed switch. So if we are considering these 3 junction as like a switch, so here I am taking J1, J2 and J3. So J1 is forward bias, so it is a closed. J3 is forward bias, so as like a J1 it is also closed, but J2 is reverse bias, so it is open. So if the circuit, if it is a reverse bias, the circuit is not closed, so there is a no current at a initial stage. Okay, so this is the forward conduction mode of SCR. So it acts as a closed switch when it is forward biased. Then coming to the reverse blocking mode, that is VAK is negative and gate current is equal to 0. That means no gate current is applied. So here the anode is negative with respect to cathode. See here, so this is a SCR. So here we are connected, that the anode is connected to negative and cathode is connected to positive. Here is no gate current, so that the circuit is open. So here, see here P is a P layer. I mean P is a P having a holes as a majority carrier, and N having a electron as a majority carrier. So as we are connected that the positive to the negative, so that the opposite poles it doesn't repel, so it attracts. So here that the majority carrier is electrons, here positive. So that these also the opposite poles, so it also attracts. So it doesn't, any of that junction doesn't crosses the junction, so that any of the charge carrier doesn't crosses the junction, so that the junction 1 is reverse biased and the junction 3 is also reverse biased, but junction 2 act as a forward biased. So this is the BE characteristics of the SCR. So here we have to know where it is the reverse blocking mode and where it is the forward blocking mode and where it is the forward conduction mode. So it is a forward bias and this one is a reverse bias. So during the forward bias, that the initially no current flows, but after some time that the current flows like this. So that is the forward leakage current. When it attains the breakover voltage, it have a drop off and then it have a sharp increase of current. So that is represents here as a shows as a N2K. So here that the small current, leakage current, that is a forward leakage current, when it attains the breakover voltage, that the breakover voltage is represents as a VBO. After the breakover voltage, there is a drop and then N2K is the sudden increase of current. So that the sudden increase of current is called as the forward conduction mode, that the SCR should in a on state. So here it is in a during the reverse biases. During the reverse bias, there is a no current flows in a circuit, there is a no conduction, but after some time it has a leakage current, that is called as a reverse leakage current. After attaining that the current to breakdown voltage, it also have a sharp increase of current, that is represent as a P2Q, that the small current that is in a reverse bias is called as a reverse blocking mode. This line is called as a reverse blocking mode. So here you have to aware of that, we can turn on the SCR by 2. We can turn on the SCR by applying the gate supply, and also we can turn on the SCR without giving a gate supply. So what is the difference between the with the gate SCR and without gate SCR means? With the gate SCR, that the breakover voltage is maximum. That means if you are applying a gate supply means that the SCR will conduct before that the without gate supply. So here I am giving a gate supply 1. So if you are changing the gate supply, that means magnitude of the gate supply, that the breakover voltage will be decreased. If you are increasing the gate current, magnitude of the gate current, that the breakover voltage will be decreased. So here IG1, that is a maximum gate current, and IG2 is the another maximum and IG3 is the another maximum. So when you are increasing the or changing the magnitude of the gate current, that the breakover voltage will be decreased. That means SCR will conduct before or earlier of that without gate. So these are the parameters